Hi, students. Welcome to today's lecture. And we'll be looking at set rules of oxidation states. Okay. We have to know this that every species or every element or molecule or compound has its own oxidation states. Okay. Which is assigned by a set rule, and there are rules that govern these oxidation numbers. And then for uncombined elements, there are about 120 elements, but I'll just be giving very, very few examples. Okay, for uncombined element, once an element is in its elemental states, free states, uncombined states, the oxidation number is what? 0. So what it means that in this type of reaction, redox reaction, you can take the oxidation number of an element to be 0. I think the reason is that once an element is in its free state, where the number of proton equals the number of electron, the sum of the total nuclear charge is what? 0. So that is on that note. Then for combined fluorine, you know what I mean, combined fluorine. Now, fluorine can combine, there are compounds of fluorine, like you have hydrogen fluoride, hydrogen, sodium fluoride. These are combined fluorine. But fluorine as an element has an oxidation state of what? 0. Are there? But as combined with maybe another element in its compound, its oxidation state is what? -1. Is a set rule. And then for combined hydrogen, the oxidation state of combined hydrogen is what? +1. Any compound of hydrogen, even this compound, the oxidation state of hydrogen here has always been what? +1. Then for combined oxygen, or every compound of oxygen, the oxidation state of oxygen is what? -2. Is a set rule. And then for simple ionic compounds, for example, I have something like sodium chloride, sodium oxide. I mean, the sum of oxygen number of all the atoms of elements in this compound is equals to what? 0. And then for molecules like diatomic molecules, triatomic molecules, polyatomic molecules, like in diatomic molecules, that's like H2, N2, Cl2. What do you think will be the state of oxidation state for this? 0. Because they are in their molecular state, so it is also what? 0. But there are exceptions to these rules. There are 2 exceptions to these rules. One is that in peroxides, oxidation states of oxygen is what? -2. Sorry, -1. You're correct. That is in peroxide. Oxygen has oxidation state of -1. Example, hydrogen peroxide. Hydrogen peroxide. If you want to know what is oxygen here, the sum of everything here should be equal to what? 0. So H, of course, combined hydrogen has always been what? +1. So how many atoms of hydrogen is there? 2. Let this be what? 2x. I want to find out what is oxygen in this peroxide. And here is equals to what? 0. Here is +2 plus 2x equals to 0. Collect like terms. 2x is equals to 0. This goes over here, becomes what? -2. 2x is this -2. So what do? Divide both sides by the coefficient of what? X. So here is what? 2, here is 2. 2 here, 1. 2 here, 1. So x alone is what? -1. Exactly. So that is the only exception apart from peroxide, every other compound of oxygen is -2. And a second exception, in metal hydride, hydrogen has an oxidation state of what? -1. Remember, it is +1 on that table, but not when it combined with metal, like in the case of what? Sodium what? Hydride. Sodium what? Hydride. Are you with me? So one thing you must know this, you must take, in fact, let this be at the back of your mind, that sometimes oxidation states of P and D block elements vary so significantly. The only one that doesn't vary here is S block. I'll give you an example. You know your periodic table, the block table, the block that's block like this. That block table like this. This periodic table. That is group 1, group 2, group 3, group 4, 5, 6, 7, and then what? 8. This 8 is a little bit, because here will be what? Helium. Here will be what? Lithium, sodium, potassium, beryllium, magnesium, calcium, scandium, stop here at what? Zinc for D block. And then here we have boron, carbon, nitrogen, oxygen, fluorine, and what? Neon. And then here we have magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and what? Argon. Are you with me? Okay, where are the S block elements? From here to here are what? S block elements. The oxidation state does not vary. All the elements here, their combined states of all the elements here is what? +1. They don't vary. You know what I mean by varying? Okay, like sometimes it varies in this compound, it varies in this compound. It will always be +1. That is the rule for S block. These two are S block. Why they are called S block? Because their last subshell is S. I think you know about this. The last subshell here is for lithium is 1s2, 2s1. So this is the last subshell. So the last subshell is S. So it's going to have one electron in that shell. So that's what makes it S block. So the oxidation state will always be this one, +1. In compound, like compound of lithium, is to have lithium oxide. The oxidation state of lithium here is +1. It will not vary. The same thing with group 2. Okay, so S block family does not vary. Then the whole of this is P block. From here to here are what? P block what? Elements. This is where it varies so significantly. I'll give you an example. The oxidation state of carbon can vary from 0 if it is carbon, because this is elemental states, to +2 if it occurs as what? Carbon 2 oxide or carbon monoxide. And then +4 if it's occur in CO2. See, is varying. It is varying. So this is because it is what? P block. Those of group 5 also varies. But take note, when they are varying, the highest state of oxidation of elements in group 4 will be the group they belong. You can't exceed their group. So the highest state of oxidation states of elements in group 4, for example, carbon, are what? Those are what? +4. And those +4 are the states that are very, very more what? Stable. Are you with me? Then, if you go to group 5, nitrogen also varies. Because nitrogen can exist as N2. In this state, it is what? 0. It can exist as what? N2O. In this state, it is what? +1. It can exist as what? NO. in this state is what? Plus 2 N2O nitrogen 4 oxide, NO2 minus dioxonitrate 3. Check it now. Minus 2 times 2. Minus 4. Minus 4, what will be here? If you add it minus 4, you have minus 1. 3. Dioxonitrate what? Nitrate what? 3 ion. See how I'm going from 0 to 1 to 2 to 3 to NO3 minus to what? 5. I think it's going to stop at this point because that's the group. Apart from oxygen, those in group 6 will stop at what states? Plus what? 6. Then those in group 7, apart from fluorine, the only oxidation state of fluorine is that of what? Minus 1. But those of any other members like chlorine, bromine somewhere here vary significantly. Chlorine can exist as plus 1. Chlorine can also exist as plus 5 and can also exist as what? Plus 7. And there is one more, minus what? 1. Don't forget about this. Minus 1 can come in as HCl. It's minus 1. Because I already know that this is plus 1, here is minus 1. So when it comes in this case, it's minus 1. It can also come as plus 1. HCl. Oh, that's oxochlorate 1 acid. How is it so? Plus 1, minus 1. Sorry, O is what? Minus 2. So what is this? Plus 1. If you add these two, have plus 2. This is 0. So this is oxochlorate 1 acid. It can also turn into be 5. Suppose you have this like this. Plus 5. Check it. Minus 2 go like this. Minus 5. This is what? Plus 5. Sorry. Minus 6. Plus 5. This is trioxochlorate what? 5. It can also be this. 4. This will be what? Minus 8. So this is what? Plus what? 7. This is tetraoxochlorate what? 7. So they vary so significantly. Even those of what? D block. So this block and this block, we tend to what? Vary. The only one that does not vary is this one that I represent here. This one can only have plus 3. This one can only have what? Plus 2. There are reasons. This is because there is vacancy in the dissolved shell. This is also because there is completely filled operator, but the rest, like titanium, vanadium, they vary significantly. Copper, for example, has 2 states, plus 1 and what? Plus 2. And that is why sometimes if you are asked to calculate oxidation states of an element in its compound, okay, we most likely consider the elements that are in that table. The elements in this table, you must take cognizance of this elements. And then any of the said element in the question that appears not to be in the table, you find out. That one will vary significantly. I'll give you an example. Supposing you are asked to find the oxidation number, calculate the oxidation number of Cr. Okay, Cr is in the D block. It varies in K2Cr2O7. Okay, assign oxidation state to element that appears to be in the table. The third table given. And if there's any exception, you should know that 2 exceptions, apart from the 2 exceptions. Okay, then the one that is not in the table, I don't think there is chromium in the table. There's no chromium there. The chromium are those ones I told you that varies. So they will vary. So that one is the one that you're going to find out in the question. It appears that since potassium is in group 1, its oxidation state cannot vary. So potassium is still what? Plus 1. Chromium is going to be what? 2x. Make sure if this is plus 1, it has to be multiplied by the number of atoms in the appearing in that compound. And then oxygen is what? -2. Make sure you multiply by the number there. So remember the rule that says sum of K to CR to O7 is 0. Substitute. This is +1. 2 atoms are there. This is 2x plus 7 atoms times -2 equals to what? 0. So here you have +2 plus 2x minus 14 equals 0. So when you collect like things, 2x is 0. This goes over here, become +14. This is what? This is what? -2. So 2x is 0 plus 4 minus 2. 0 plus 14 minus 2 is what? +12. I remember that. So what do you do? Divide both sides by 2. So 2 here, 1, 2 here. So x alone is plus what? 6. This is going to give you a clue to naming this compound. Now, if you look at this compound, look at how to name. The first element here in this table is potassium. After potassium, this is where chromium is supposed to be chromium. Well, since chromium varies, it's going to be named last. So it means that oxygen that comes after will be named before chromium because its states vary significantly. So how do we name this? The name potassium comes first. So the name is going to be what? Potassium. Oxygen is 7 of it. So the prefix it have to have hepta is going to be oxo in this compound. Oxo, then 2 of it chromium dichromate. Why is going to end in 8? Because in this case, chromium has a positive oxidation state of what? 6. Make sure it is written in Roman numeral in brackets. This is 6, isn't it? So that's right. So potassium hepta, oxo dichromate what? 6. Okay, then oxidation states in molecular ions. Molecular ions are those group of ion that contains atom of oxygen, and they are most often negatively what? Charged. These are called molecular what? Ion. We have examples shown on the screen. I'll just explain very few of it. Okay, you are aware that the sum of oxidation state of oxygen is always being -3, isn't it? So if you look at this molecular ion, OH, of course, this is going to be not minus. The sum of both of them is -1. How? -2 plus 1 is -1. So the oxidation state of OH minus is what? -1. Are you with me now? The oxidation states of MnO4 minus is what? -1. Find Mn here. The rule is that the sum of oxidation states of all the atoms or in an ion like this, all the atom is in an ion is equal to the charge on the ion. The charge on this particular ion is -1. So everything is equal to this ion. Okay, so let's find Mn. Already you know that this oxygen has always been what? -2. So let this be what? X plus 4 of the atom of oxygen minus what? 2 equals to minus what? 1. So we have X minus 8 equals to -1. So X is equals to -1 plus what? 8. X is what? Plus 7. This is going to give you a clear case of naming the compound, very clear case of naming the compound. No, you're not going to start with this Mn because it is variable. So start from the one that is very most kind of stable. So starting from oxygen. So the isopack name is what? Tetra, oxo, It's not going to be called manganese again. It's manganese if it's in elemental states. But manganese, manganese, what? You just got 7 in Roman figure. V, I, what? I. And it's in ionic states. You must put what? Ion. Okay, do this quickly. Calculate the oxidation states of Cl in ClO3 minus. Give its IUPAC name quickly. Sometimes when you're giving something like this in an objective, you don't even need to solve it. Just what would be here After multiplying this, you have minus 6. What number will be if you add the minus 6, you have minus 1? That number is what? Plus 5. I'll say Cl minus, or our viewers to understand, minus 1. Let this be x until you find what it is. 3, who is minus 2 equals to minus 1. X, this is minus 6 equals to minus 1. X is minus 1 plus 6. X man is what? Plus 5. So that's going to help you to name the compound. It's not going to end as chlorine or chloride. Chloride is when chlorine is combined with maybe a lower element, an element with low electronegative value, like HCl. It's going to be chlorine because it's going to be negative here. But in this case, it is positive. Okay, so it's going to come as chlorate. What we end it is 8. So this is going to be what? Trioxochlorate what? V. What? Ion.